All right, good morning, guys. Grab a piece of paper, grab a pen or a pencil, and get ready to take notes. Make sure you're definitely taking notes because you are at home for every test and for every homework assignment. So nobody's going to tell you not to look at your notes. So you might as well take good notes so you can use them. All right, today we're moving into 6.1. We're moving into chapter 6, starting off the second semester. We started with a little bit of review, but now we'll move into the new stuff. So chapter 6 is all about properties of exponents. Properties of exponents. How do exponents work? Properties of exponents. So first thing we've got is you've got something that looks like this. This is what we're talking about. Here's an exponent, x to the m, where x here is the base and m is the power. X is the base and m is the power. And the power says multiply the base by itself that many times. So you'll multiply x by itself m times. That many times. X times x times x times x times x. Multiply x by itself m times. The base, the power. So, first example would be something like this. Say you had something like 2 to the 4th, where 2 is my base and 4 is my power. So 2 to the 4th would be 2 times 2 times 2 times 2. There are 1, 2, 3, 4 2's. The power is 4. So 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 to the 4th is 16. So there's a simple example of an exponent. And now these properties of exponents, we've got a lot of rules today. A lot of rules. Make sure you write them down. There's a ton of different ways to use these things. So let's write down all these rules. And the first rule that we want to talk about is called the product. Oh, there's a C in there. The product of powers. I would organize them like this. Product of powers. The next one's going to be quotient of powers, power of power. Organize them so it's very easy to find these rules. So the product of powers looks like this. If I have two exponents multiplied by each other, two exponents multiplied by each other, and they have the same bases. It's important that there's the same base. They're both x. X to the m times x to the n. What we're going to do is we are going to add the exponents, x to the m plus n. So an example of that would be if we had 3 to the 4th times 3 to the 3rd. 3 to the 4th times 3 to the 3rd will be, the base remains the same. And up here it says if you multiply them, then we're going to add the exponents. So we will add the exponents. 4 plus 3 is 7. That will be 3 to the 7th, which is 3 times 3 times 3, 7 times. The next rule is called, after the product, that's when you multiply things, we'll go to the quotient of powers. Quotient is division. So now we've got something, x to the m over x to the n. So the quotient is the opposite of a product. Division is the opposite of multiplication. So the way I remember this is if I'm multiplying, and that means I end up adding the two exponents, Well, here, if I'm dividing, now I'll do the opposite of that addition, and I'll end up subtracting the two exponents. So the base remains the same. X to the m divided by x to the n means I now have x to the m minus n, where above I added them, now I'm subtracting them. And this example works out nicely. So say I have, let's use these same numbers, 3 to the fourth over 3 to the third. Well, that's going to be 3 times 3 times 3 times 3 over 3 times 3 times 3. I have 3 of them down here. I have 4 of them up there. And now you could see that they just cancel, and I end up with 3 to the first. Well, if I used my rule, then I would know that I would just do subtract them. It's also equal 3 to the 4 minus 3, which is just 3 to the first. Well, that means it's just 3. Oh. Sorry, I was off the page. Get caught up there real quick. So we had the product of powers. We have the quotient of powers. Now let's talk about the power of powers. I say it's like raising a power to a power. All right, so now let's say we have x to the m in parentheses to the n. X to the m to the n. And what you do here is you end up multiplying those powers, x to the m times n. So an example for this one will be something like, say I had 3 to the fourth to the third. If I have a power to a power, it says that we are going to multiply the 4 and the 3, multiply the two powers. So we get 3 to the 4 times 3, which is 3 to the 12th. So the power of powers, you multiply them. Power to a power, you're going to multiply them. Then we've got power of a product. So up at the top, we had the product of powers, where I had two powers and I multiplied them together. Well, now we've got the power of a product. The power of a product means I've got the multiplication going on in the parentheses, and then I've got my power out there. So here I've got x times y, but now in parentheses, both of them are being raised to the m power. And I talk about this one. This is my shower the power rule. We've got a couple of shower the power rules, and this is one of them. That means it's almost like distribution, how if you had a number in front of here, you distribute it to two terms, but here they're being multiplied. So it's not two terms, it's these two factors that get my power showered. So that means this will be x to the m, y to the m. The m power, the exponent, gets applied to both of the bases. X to the m, y to the m. And for the example, I want you guys to, if I just put two numbers in there, 3 times 4, you would do the parentheses first, and you'd just say it's 12. So let's put like 2x. Let's go 2x squared. So I've got a product in here, and I've got my exponent, my power up there. And what I'm going to do is I'm going to shower that power down. So now I get I'll get 2 to the second, or 2 squared, and then I've got my x to the second, or x squared. And I'll always want you to simplify that further, because 2 squared, 2 times 2 is 4. So the final answer there would be 4x squared. Now I'm going to put these two together because these are very similar. So now let's look at the power of a quotient. So we had the power of a product, and now we've got the power of a quotient. So now we're going to have some division inside the parentheses. We will have x over y to the m. And the shower is going to work in the same way. We're going to shower that power down to those two things. So now we will get x to the m over y to the m. The exponents applied to both the numerator and the denominator. So as an example here, let's take some fraction that we wouldn't simplify or divide, and we'll go 2/3 squared. 2/3 squared, and you will rain down that squared onto both of them. So I will have 2 squared over 3 squared. 2 squared is 4, over 3 squared is 9. All right, we have 3 more rules. 3 more rules. And the next one is a very friendly rule. The next one is the zero exponent rule. The zero exponent. It's a wonderful rule. As you go further and further into math, you always enjoy a zero exponent. It makes things very nice. What it says is x to the 0. X meaning it could be any number. Any value can be x, right? X is a variable. That could be 0.5. That could be pi. That could be a million. It could be negative a million. When anything is raised to the 0 power, the answer is 1. Anything to the 0 power is 1, is what this rule says. So if you do 14 to the 0 power as my example, the answer is 1. Anytime you see an exponent as 0, you say thank you. Now let's look at negative exponents. There's 2 negative exponent rules. And after you guys finish the ed puzzle, your teacher will explain to you why the negative exponents work the way they do. If they forget, ask them. Why do the negative exponents work the way they do? But for now in this video, all I'm going to do is show you the rule and make sure that you have it written down. The rule looks like this. If you have x, any number, right, to a negative power, what happens is x to a negative power wants to go to the other side of a fraction. So right now, this is in the top of a fraction. You could always put this over 1, right? Anything could go over 1. And what happens is this negative exponent makes it want to go down. So now I'm going to put a 1 on top. And this is x over 1 to the n, or 1 over x to the n. Sorry about that. So a negative exponent takes this exponent in the base and puts it down into the basement. It sends it down into the denominator, and you get a 1 on top. Also, like I said, it sends it to the other side of a fraction, not just from top to bottom. If you have 1 over x to the negative n, what's going to happen is this wants to go up. So that equals x to the n. And you could put it over 1. Obviously, that doesn't matter, right? Anything could be put over 1. However, it makes it easy to see that this goes up and that goes down. makes it easier to see that that is in the top of a fraction. All right, guys. So there are all of our properties of exponents. 6.1, we're going to practice with these a lot now today. All right, have a good one.